All right, welcome friends. So we're going to do practice test 11 here today. As you can see, we're going to do module 1, module 2 should come a little bit later. So I'm going to give you my unsolicited opinion here about this test. Overall, I think this is a pretty good test. There's a lot of these tests where some of the questions near the end, as a math kind of educator, I kind of scratch my head about what they're assessing on some of these questions. This one I think is pretty good overall. It's a pretty good mix, a little bit geometry light, I guess, but overall a pretty good mix. So why don't we just jump right in? The first half I go through pretty quickly, so if there's something that you need, a little more time on, just pause it and go back. But just for the sake of the length of the video, I'm going to go through this kind of quickly, right? Thinking about what I would do if I was taking it kind of in the moment. Right, so let's jump right in here, right? So number one, kind of a little extraneous information, right? Like I don't need this to figure out what x is, right? I can add 24 and 132 and subtract that from 180. The fact that these two are equal is going to tell me that x is equal to 24. So I guess I saved myself 5 seconds worth of time and work there. But even if they didn't give that to me, right, x plus 24 plus 132 is 180. Number two, right, 4x is equal to 32, right? So moving right along here, it says the line has a slope of 7, okay? So, I don't need to look any further than that. Sure, it's got a y-intercept of 5 also, but some of these questions, right, like you can eliminate all the bad choices with one piece of information, right? Number 4, we know we're going to add 40, right? We get 8x squared is equal to 72, right? We realize that x squared is equal to 9. Taking the square root means x can be equal to plus or minus 3. They're asking us for the positive root, so we end up with positive 3. All right, number 5 says, what's the probability of selecting a vegetarian? They tell you that there's 50 children. They also tell you here, so you don't have to add. A vegetarian is going to be 9 out of those 50, so not that much to do there. For this one, it says she harvested 750. She gave away 10%. How many did she give away? So we just want to clarify whether they want to know what she's keeping or giving away. So obviously finding 10% of a number should be pretty easy, right? Because we're just dividing by 10. So we should end up with 75. Oftentimes when we see a system of equations on the SAT, at least towards the front half, it's just a substitution system. So I'm going to think about the fact that if I know that x plus y is 125, I can replace this with 125, right? So we add negative 125 on both sides, and we get y is 30, right? We actually don't want to combine the like terms, because if we combine the like terms, it's going to make it more difficult. We may have to solve for y or solve for x and substitute. So use the information that they give you and just straight substitute what x plus y is equal to. Next one is pretty common. We just want to match up the coefficients with the information. It says 1 point for each draw, 3 points for each win. So it says D is the number of draws, so the coefficient of D should be 1. And the number of wins, the coefficient should be 3. And altogether we have 41 points. We can put that together pretty easily for choice A. Number 9, pretty typical, right? So you got to just be careful. Sometimes they'll say, what's the value of x when g of x is equal to blank? And then we're going to substitute for g of x and solve for x. More typical is if x is equal to 81, g of x means we replace the x with 81. So it becomes radical 81 plus 300. Right, so 9 plus 300 should get us 309 pretty easily. All right, the next one is a sampling question. So it says that 8 out of 300 people felt a certain way. We want to know what that would be out of 30,000, right? So certainly we can cross multiply here, but I would think we should be able to say that there's clearly a multiplier here of 100. So we want that same multiplier here, right, to get us 800. Number 11 I don't love, right? Because really, if your algebra is strong and you look at this question, you're going to factor out the GCF. Now the GCF is not any of these, right? Because obviously, all of these have a common factor of 2, right? The GCF is going to be 8, right? 8 what? Well, it turns out it's going to be 8t squared s, but that's not what they're asking you. Which expression is going to be equivalent? So we kind of just have to check the choices, right? Because again, it's not a true factoring question, at least not factoring out the greatest common factor. So if I distribute here, I get 16, I get s cubed, and I get t. So I don't get t squared, All right, so that's no good. Here, I'm going to get 64, which is great. I'm going to get t cubed and s cubed. Well, that's too many powers of t because I want t squared. For the next one, and when I distribute, I get 64 t cubed s squared. So it's got the powers backwards, right? That was kind of a trap. And when I do the last one, I get 64, right? I get s cubed and then t squared. And just for clarification, if we want to do this here, we get this. So obviously d is the only one that works. Number 12, we solved the first equation for x, right? They're giving us that x is equal to 9. So y is equal to 4 times 9 squared plus 4. Obviously, we're going to follow order of operations. We get 4 times 81 plus 4. So really, I can do 81 groups of 4 and 1 group of 4. I could do this as 82 groups of 4 if we wanted to, right? Or alternatively, just do 4 times 81 is 324 plus 4 is 328, and that's y. So we get 9 comma 328, right? I guess a is if you forgot to add the 4. So far, I think this has been pretty easy. This one is also a pretty easy one, so you can read the question. It says there's 6 of these Lincoln grade pennies, right? So it says the number of Lincoln grade pennies is y. So really what they want me to do is substitute 6 for y. Now I'm pretty sure if you substitute 6 for x, you're going to get a decimal. Now that's, in general, right, we can have answers, right, in math that are decimals, right? Certainly if we're talking about the cost of something, a decimal would not be a problem. But if they say how many pennies and you get a decimal amount of pennies, we know that that's wrong, just like if we get a negative number, right? So that tells me it should be 13. So far this test has been pretty easy. It does get pretty hard at the end. This one starts to get a little harder. So it says the population doubled every 75 years from here, right? So maybe you can't see that. From 1659 to 1959. So the first thing is, how many times did it double? So it doubled 4 times. And at the end, we end up with 240,000. So if I'm going to use an exponential growth function, which is absolutely not necessary to do, I'm going to say, well, I'm going to start with 200, or I'm going to end with 240,000. And that's equal to my initial value times my growth factor, right? 2 to the 4th, right? Because it's doubling 4 times. So if we're doubling 4 times, we're multiplying it by 2, right? Double to the 4th power. So algebraically, and you don't have to do this algebraically, we end up with this, right? So we divide both sides by 16. 24 divided 16 is 1.5, so 240 divided 16 is 15. And then we get those 3 zeros, so we get 15,000. Now, alternatively, you can just kind of run this thing back 4 times, right? So if we ended up with 240,000, what happened before we doubled? Well, that would be 120,000. I don't need the zeros. I could just put a K, but I'll continue along these lines. What happened before we doubled, and what happened before we doubled. So there's my 4 doubles, and we can see that it checks what we've got over here. So it should be 15,000. 15, we get back to a pretty easy one, right? So I don't need to do a whole lot of math here, right? We look at the axes, and the axes are both, the intervals are the same. Now, if the intervals were not the same, then we'd have to be very specific, right? In other words, if the intervals are the same, I can say that going up 1 and over 1 is a slope of 1. So this is going to be flatter than that, right? Which means my slope's going to be less than 1. Well, that kind of gives me my answer, right? It's not as satisfying, honestly, because, the points are all, most of them are approximations. I guess we have 1 here, right? So this is 3 comma 5. And let's see if I can grab another one, sort of, right? So this is going to be what? 8 comma 8. All right, so if I do my slope formula, y2 minus y1 divided by x2 minus x1, we get 3/5, which is 6/10. Okay, so it does check out doing it that way. But again, just identifying the fact that that's slope, right? Because if I started here and I went up 1 over 1, right, that's going to be a slope of 1, right, that red line. Well, this is clearly flatter, so the slope is going to be less. Which quadratic equation has one distinct real solution, right? So we're going to say, well, for each of these, what would we do, right? We're going to take the square root of both sides, right? Now, 0 is kind of an important number here, right? Because if I take, let's say I take C, right, square root of both sides. I'm going to get x plus 15 equals plus minus radical whatever number is under there, right? Now, so I don't need to solve this, right? The fact that I have a plus minus here means I'm going to get two solutions, right? What's wrong with choice B? I get a negative there, so there's going to be no real solution. So C and D are the same, right? I'm going to get two real solutions, right? Really, it comes down to the discriminant, but we're not going to mess with that here. What's going to happen for choice A? Well, we're going to get x plus 15 equals plus minus 0. Okay, well, there is no such thing as positive or negative 0. So really, this comes down to x plus 15 is equal to 0. Sorry, that's an equal sign. Right? Because look, if I substitute for a negative 15, I'm going to get 0. That's the only value that's going to give me 0. Okay? So the only one that's going to have one real solution is A, right? B will have no real solutions. C and D will have two real solutions. All right, 17. So this is kind of a tricky one, right? So when we have problems where there is a cost for the first, usually it's the first hour. Now it could be the first anything, right? But if it's the first hour, right, and then you're paying for an additional hour, right, the expression we use is x plus 1, right? If I'm paying, let's say this was the $9.50 for the first hour and 50 per each additional hour, right? If I rented something for 10 hours, right, I'm not paying $50 10 times, right? Because I'm paying this for the first hour. So I'm paying the extra amount 9 times, right? The total amount minus 1. So what we want to think about in those cases is I'm paying for the first hour a certain price, usually a higher price, and then I'm paying another price for each additional hour, so each x minus 1. Now this one's a little more tricky because it's the first 3 hours. So I'm paying $9.50 plus, what am I paying 50 for? Well, if I rent for 10 hours, that $9.50 covers my first 3 hours. I'm paying for the extra 7. Where did I get 7? 10 minus 3. So we're paying 50 for each of those x minus 3 hours, right? So it's not x minus 1. That's typical. But this is the first 3. So I'm paying $9.50 once, and however many total hours I'm paying, I already paid $9.50 for those 3. So the total number of hours minus 3 is the number of hours I'm paying the 50 for. Well, to me, that certainly only looks like choice C, right? $9.50 plus 50 times the quantity T minus 3. All right, so a lot of different ways we can do this one, right? So first things first, we should be able to tell that D has a horizontal line. So that would be y equals, I don't know, 53, I guess, would be the horizontal line, but that's not what's here. Second thing we can do is we can use the intercepts, right? So the first one has intercepts of 53. So there should be a line with an x-intercept and a y-intercept of 53. Okay, so this one is out. All right, C looks okay. And I've got 53 here and here, and B looks okay. Okay. Now, what about the other one? Well, this is going to have, sorry about that, this is going to have positive intercepts too. What are the intercepts? Well, 730 divided by 11 is going to be the x-intercept, and 73 divided by 18 is going to be the y-intercept. Let's say I don't even care about that. Let's say both of these will have negative slopes, right? Because if I solve this equation for y, right, I don't even have to really do it, but at this point, I know that the slope is going to be negative. Well, both of these have negative slopes, right? Because the first one is going to be y equals negative x plus 53. So this line with the positive slope is no good, right? So I could have approximated the intercepts, and I did that as well, right? So if I do 730 divided by 11, I don't know, let's approximate that to about 60. Okay, that seems pretty good. What about 730 divided by 80? I don't know, let's call that about 40. Okay, so that checks the box if you just wanted to, like, you have a calculator, right? Which I typically don't use with these videos. I try to reinforce the mental math aspect, but I can approximate my intercepts, which is what I did. But again, we know that the slopes of both of them are going to be negative. The only choice that's got 2 negative slopes is B, so that should have been a pretty easy one. You can also, if you're using Desmos, if you're using the traditional graphing calculator, you have to put it in terms of Y. Desmos now will let you just put it in any form, so that should have been pretty easy that way too. This one was a little bit tricky. So we want to know QS, right? So I'm going to call this equal to X. And all of these are in terms of angle Q, right? So that's going to be my theta. Now in terms of angle Q, this is going to be my opposite. And this, of course, is my hypotenuse, which tells me I'm going to use my sine ratio. So sine of theta is equal to my opposite, right? Go back to SOHCAHTOA. divided by my hypotenuse. So let's just fill in what we know, right? The sine of theta. Oh, I think I just kind of rewrote what I needed. Now, all right, good. So there we go. So that sine of theta is really going to be q here, right? So let's just change that to a q. Now, something we know about a proportion, right, is that if we have a proportion, we could always switch to cross products, right? So I can say a divided, if this is my original proportion, I can literally do that, right? Because in both cases, my cross products, AD equals BC, are equal. Now, when is this usually valuable? Well, if I have A divided by B equals C, and somebody says, well, solve this equation for B, right? Well, traditionally, what would we do? Multiply by B and divide by C. Well, that's too much work, right? Why don't we just swap these out, right? And A divided by C is equal to B. Why am I mentioning that? Well, because I want to solve for x, so that's exactly what I'm going to do, right? 18 divided by sine q. Right? Alternatively, what would you do? Multiply by x, right? We'll get x sine q equals 18, divide by sine q. But, we want to think smarter, not harder, right? Really understand there's a lot of different ways that we can manipulate proportions, specifically doing this, okay? Especially for a problem like this. All right, so our equation of a circle. Now, when we read this problem, all they care about is the radius. Everything else, the whole left side of the equation is noise. Right, so we know that if we're going to do, right, x minus h squared, right, y minus k, right, the whole part here, and this is an equation that we do need to know, right, they don't give this to us in the formula sheet. In this problem, we need to know that that's r squared. All right, okay, so my original circle, circle A, has a radius of 5. The radius of circle B is double that, fantastic, so the radius of circle B is going to be 10. So if this is equal to my radius squared, then k is equal to 10 squared, and it's just going to be equal to 100. So if you understand, if you don't know the equation of a circle, you're going to be kind of lost there. If you know the equation of a circle, that should be pretty easy then. Again, we don't need anything about the left, right? We don't need to know that the center here is going to be negative 5, 5 or anything like that. They just want to work with the radius. All right, let's make sure we know the quadratic formula, right? So I shouldn't have to write this down, right? But if you show up at the SAT, right, negative b plus minus, square root b squared minus 4ac divided 2a, if you show up without knowing the quadratic formula, you're going to have a tough time, right? I've had students that are like, oh, I'm going to complete the square. You don't want to complete the square if the coefficient is odd. And certainly if this was, if the a term's not 1 and the coefficient is odd, good luck, right? So, we want to know the quadratic formula. We want to understand the value of the discriminant, that it's going to give us the nature of the roots. We don't see it on this module, but we do see it on other modules a lot at the end of the test, right? What's the biggest value of A that will give us real roots or imaginary roots or whatever? Okay, so I'm just going to use quadratic formula, right? So negative b plus minus square root. I mean, we really just need the discriminant here, right? I'm going to go through the whole process, right? B squared minus 4ac, right? So just as a refresher here, right, a is the coefficient of x squared, b is the coefficient of x, and c is the constant. Again, these are things we definitely need to know when we go into the SAT. So this is going to be what it's going to look like. Now, why am I actually writing out the rest of the formula? Just in case they simplified the radical. Now, the fact that the negative 7 is there, I know that they didn't, right? So we get plus minus 49 minus 20 divided by 2. All right, so radical 29 out of 2. Okay, so what is the value of k? That should be easy, right? The value of k is 29. Right, again, you don't want to be, and if you complete the square, you're going to have to simplify the radical. Right, completing the square is generally not going to give you a denominator like this, right? So you're going to have to then figure out, you're going to have to multiply your answer by half to get the denominator. So not something we want to be doing. All right, so this is one where I'm going to lean on using a weighted average, right? Again, I know we have a calculator for this, right? But it says 240 gray seals, right? And they had an average of 88. And 120 gray seals had an average of 94, right? So yeah, we can do 240 times 88, right? Plus 120 times 94. And divide it by 360, right? Fantastic. We can do that. But I'm going to think about the fact that this is really a 1-to-2 ratio. So it's just like if I had one group of 94, right, and two groups of 88. And if I want to take that concept even further, just kind of leaning on the mental math, sure, I can add these up and divide by 3, but I can think about, well, why don't I take 4 away from here, and I'm going to give 88 2, and I'm going to give 88 2, and now my average is a 90. So again, leaning a little bit more on the kind of conceptual mental math angle of this, even though you can just pop this whole thing in your calculator. All right, this is the first one I thought that was considerably more difficult, right? So a couple things here. We have a translation of this function, right? So this is the graph y equals f of x plus 4. So what is f of x equal to? Well, this is what happened. So this is the original one, right? Translated up 4 units, right? We know if we have plus 4 outside, right? Inside, different story, yeah, right? That's left, right. Those are horizontal translations. This is going to be a vertical translation. So if I want to know what f of x looked like, f of x would be if I took this whole thing, right, and I moved it 4 units down. So instead of 0, 8, I'd have 0, 4. Instead of 1, 6, I would have 1, 2. Instead of 2, 0, I would have, I'm going to go down to 2, negative 4. So it's essentially going to look like that, right? That's the translation of my original, that's f of x, right? This green thing is f of x. Now, what I'm going to do is I'm going to grab some points from f of x. And this is not maybe the typical way of doing it, but it's going to work pretty effectively. I'm going to take those 2 points. And I'm probably going to lean like on the second one, because the first one actually is going to give us a little trouble with the order of operations. I'm going to say, well, when x is equal to 1, with my first one, I'm going to get negative 3 plus 1 is negative 2. With my second one, if x is equal to 1, I'm going to get this, right? And that seems like it works pretty well. For my next one, if x is equal to 1, right, I'm going to get negative 3 plus 8 is 5. And with my next one, it's going to give me 6. So none of those work. Now, why did I want to avoid 0? Well, because negative 3 to the 0 plus 5, I know I'm going to have people that are going to say, well, negative 3 to the 0 is plus 1, is 1, right? Anything to the 0 is 1, which is true. Except that's when the negative 3 is in parentheses, right? Which here it's not, right? Technically, it's not in parentheses. Means we're going to have to use order of operations, which means we do 3 to the 0, which is 1, right? And then the negative gets applied. And then we do get 4. Okay, so we do have to be a little bit careful. So if you want to avoid that, right, because again, technically it's not, you could literally see it. I'm looking at it. I don't see parentheses there. Okay, we're going to substitute it just as is. But if you just lean on 1, 2, the only ordered pair that's going to have that is the second one. But you need to understand that this is a translation 4 units up, which means my original function has to, which I have in green, kind of wonky looking, is going to be 4 down. All right, 24 is it's an unusual question, but it's easy. So we have, it says 2 lines intersect at a point forming 2 acute angles and 2 obtuse angles. All right, so I mean like that, right? We don't really get, it's a stupid setup. They could just say we have vertical angles, fine. So it says one of these is 9x minus 40, okay? So I don't care which one it is, right? So if this is 9x minus 40, this is 9x minus 40, the other angle is going to be the supplement, right? So the 180 minus the quantity 9x minus 40. So let's make sure we distribute that negative. Sorry, that's 140. Let's drop that in there. My beautiful handwriting. So we get, plus 140. So sorry, we get 320, right, minus 9x. Okay, so that's this angle. All right, so it says, which could not be the sum of the measures of 2 of these angles? Okay, well, if I add the blue angle with itself, it's going to give me 18x plus 280, right? Right, okay, so, sorry about that. That's a minus. My handwriting is killing me today, sorry. So 9x minus 140, sorry. So that's going to be 18x. Let's do this the right way, right? 18x minus 280. Okay, so 18x minus 280, that's good. Certainly, if I add these two, or any pair of adjacent angles here, it's going to give me 180. And I'm going to say, well, what if I add the pair of angles that's here, right? Well, that's going to give me 180. What happens if I add these two angles? Well, if I add these two angles, it's going to be 640 minus 18x. Okay. So this is the one I didn't get. So what did I have to do in my very sloppy way? I had to add the two red angles. Maybe they're obtuse, we don't really know. I had to add the two blue angles. And I know that the pair of angles, it's a linear pair, is going to be 180. The first thing we had to do, though, was take the supplement. This was the most important piece of information for this problem, is to find the two angles algebraic. I mean, they gave us one of them. So the supplement of that is, so just to make this a little bit neater, right? One angle was 9x minus 140. The other angle is 320 minus 9x, right? Because if I add those together, the 9x and the 9x is 0. 320 minus 140 is 180. So doubling the first angle was 18x minus 280, right? We said check. Doubling the second angle is 640 minus 18x, check. Adding the two angles, the acute obtuse pair, the linear pair is 180, so A doesn't work. Sorry about that. Okay, number 25. So it says there's at least one solution. Okay, so what does that mean? Well, it means that the equations could be like, if I have 2x, so let's recap. Let's recap no solution. Right. If I decide to put any number other than 7 on the other side of this parentheses, this is no solution, right? Because if we look at this, 2x plus 9y can't be 7 and 4 at the same time. What if we want infinitely many solutions? Well, then we have to put 7, okay? How do we make it so that there's one solution? Well, make something on the left side different, right? Make this 3x. That would be enough. Change the coefficient of y. Okay. So the first thing then we really have to do, I'm going to make some space here, right? So 2x plus 9y equals 7. And then we have 3x plus 13.5y equals 10.5. And then we have the same thing with minus. Now what I'm going to do here is I want to get rid of these fractions, right? So I'm just going to do this once because it's going to be the same. So let's say I decide to, I'm going to double this, right? So 6x, and if I want to be really savvy, there's something else I can do, but, right, and I'm going to divide by 3. All right, so 2x plus 9y equals 7. Well, that tells me that this one, that's why I said I'm going to do it once, minus 9y equals 7. So let's think about this. This first equation and this equation are the same. They will have infinitely many solutions. This equation and this equation can be solved using elimination. So if I add those two equations together, I'm going to get 4x equals 14. Now, I don't care what x and y are, but it is solvable, right? Because like I said before, make something different about the left sides. We made something very different. We made the sign of the coefficient of y different. So I'm going to get whatever x is equal to, it looks like 3.5, and I can substitute, and I think y is going to be equal to 0. It doesn't really matter, though. So both of these, one of them will have one solution, and one of them will have infinitely many. Now, based on the parameters of the problem, which will have at least one solution? Both of them, right? So it's basically just saying, is there anything that's going to have no solution? Well, no, right? One has one has infinite, so they'll both have at least one solution. As far as question number 25 go, that wasn't too bad. Same thing, I don't think this one is too bad. I'm going to label my length, my width, and my height. So it says the base area, right? So we're going to assume that that's the length times the width is 24t. Okay. So the length of the base is going to be 8/3. Okay. So if I want to find out the width, 8/3 times the width is equal to 24t. Okay. So I'm going to multiply both sides by 3/8, right? Because that's the reciprocal. And it tells me that the width, right, 24 divided 8 is 3. The width is equal to 9t. And we can check that really easily. If I multiply 8/3 by 9t, I'm going to get 72/3, or 24t. And it says the height is 15. All right, that's pretty easy then. All right, so what do I want? I want the surface area. All right, so I've already got this part, right? So when I go to do 2LW, right, because it's 2LW, and you can do this in a lot of different ways, right? If you want to just do one of each of those, add them up and double the sum, that's fine. But 2LW, that's done for us, right? They gave us that, right? I mean, I don't have to do it again. Now, how about 2LH? Well, it's going to be 2, right, times 8/3 times 15. So 15/3 is 5 times 2 is 10 times 8 is 80. That should be pretty easy. And then 2WH, that should be easy too, right? 2 times 9t times 15. So that looks to me like 2 times 15 is 30, times 9 is 270t. So if I add up my two t terms here, realizing that, I'm sorry, they gave me LW, right? So 2LW is double that. So I made a little bit of a boo-boo there. So this and this add up to 318t. And of course, we've got our 80. So make sure that you're careful, more careful than me. I was so excited that, hey, they gave me the area of the base. I didn't double it, right? So I didn't do the 2LW part. I just did the LW. So you can see that when we double it, we get 48t. We add it together, we get B. And finally, this one is kind of deceptively easy, right? They give us all this information. So I started this and I said, all right, it's a linear function. Great. Let me make an equation, right? X and f of x or y. And I'm going to say, well, okay, well, it's when this is 3331, this is 433. And if it's 4500, this is 600. And what I did at first is I wrote the linear equation. I got this wacky slope that didn't simplify. And I said, well, why am I doing this, right? They just want to know what this equation is. I'm going to say, okay, let me take the easiest value to use because of that. So I'm going to say, okay, when f of x is equal to 433, and I'm just going to substitute, that's equal to 1/7, right, of x, which is 3331, minus a, which we're trying to find, plus 433, right? So I'm literally just using their equation. I don't care about this value, right? That's noise. The 1,000 and the 6,000, right, is definitely noise. They're just basically saying, solve this equation for A. And it's an easy equation because I got 433 on both sides, so this is really 0. And I'm going to multiply both sides by 7 because, like a quadratic, I got 0 on one side. Fantastic, right? So now what happens here? I get 0 equals 3331 minus a, and a is equal to 3331. So kind of deceptively easy there, I thought, right? But that's it, right? So again, overall, I thought this test was pretty fair. There were some pretty good questions on there. There were not really any of those questions I scratched my head about, like which of these could be the coefficient or the constant to this exponential function. And we see those here and there. Anyway, I hope you enjoyed the video. Any questions or comments, please let me know. And more to come soon.